Hey, what's up, guys? This is Steven with the MacSpace Mac Repair. I got an actual A2141 MacBook Pro 16-inch 2019. Customer came in and the computer was actually not turning on when they came in, and then when we plugged it up, the computer started turning on. And then the board eventually died, and basically the customer was able to get their data, which was pretty cool because when their computer did turn on, they said it was not turned on for months, and then it finally turned on. We tried a charger turned it on, 96 watt, boom, turned on. We said, since it's on, let's go back up your data now. So we did time machine on her data. There was no charge. Only thing she had to buy was a backup, an external thumb drive, and we got her data backed up. So we're in the clear on that. However, her board did die. No corrosion is what she said. We looked at the board, looks like there's no corrosion. I looked at the board, there's no corrosion so far, but I haven't pulled the board out yet, so we haven't tested. I did a quick check on PP bus, and there was literally no voltage going to that area. There was no 12.3 volts, no 12 volts period, and there is an actual short on PP bus, but it just magically died. So there is definitely a board related issue that she was talking about, and that board related issue did replicate itself finally. So it reared its head and decided to show up. So what we're going to go ahead and do is pull this board out, pull up the thermal camera. We're going to put the thermal camera on the actual the program so you guys can see what's going on, and we're going to go from that. I do want to say in advance, mind the mess. We have been really busy. My desk is crazy. I haven't had a chance to clean it up because I've been getting repairs left and right, and I am booked up to my neck right now. So, and there's a lot of board repairs, so there's probably gonna be a lot more videos coming out here shortly. So let's go ahead and get started. We're gonna go ahead and put this over the overhead and show you what we got. Also, the overhead now, we do have a better light overhead, so their lighting is a lot better now. So as you can see, the quality of the repairs are gonna be a little bit more better. So I will love for you guys to see what we're gonna be doing here. So if you're here to watch videos, or if you're from TikTok or YouTube and you enjoy our videos and you enjoy the repairs, please, by all means, follow our page, subscribe to the page, and go from there. And then continue to support us. Hit the like button, the heart button, whatever platform you're on. Go ahead and continue to support us. And if you would like a repair by yours truly, go ahead and go check us out, the MacSpace Mac Repair, www.themacspace.com, and we will try to help you as best as we can. Again, another thing and another disclaimer is that we are not affiliated or endorsed by Apple Incorporated. We are an independent repair shop. With that said, let's move forward on this repair. So let's go ahead and see what we got. We got all this right here. So what we need to do is get some power to the board and get some readings. So let's go ahead and get a reading real quick. Let's grab our tools and do that. I should have been prepared a little bit there, but I'm a little bit behind, so trying to catch up. Grab our cable, and we're going to plug this bad boy up to a 96 watt. Because why 96 watt? Because this board only takes a 96 watt. You can use a higher wattage, but you want to use a supply charger, and you want to make sure that it's a genuine Apple charger. Why do I need to use a genuine Apple charger when I can just buy one from Amazon? Literally, I'm just going to tell you right now, don't be the one that buys a knockoff charger. You'll end up here. So you don't have to get a brand new one if you don't want, but just make sure it's a genuine Apple charger. All right, so we're going to go ahead and check the reading on here. The board is giving us, let's go ahead and get this, take a look at it right here. The board is getting 5 volts, 0 amps, and the battery is connected. So let's see what happens when we disconnect the battery and go from there. Okay, now let's plug it up again. Five volts, 0 amps. Okay, so we're gonna go ahead and test. Again, we're gonna check out PP bus. We got power going to this. So we're gonna leave the battery disconnected because we want to see what is going on PP bus real quick. And if you guys are curious what PP bus looks like, okay, so we're gonna go ahead and do a quick check on this area and see what the voltage is. So let's go ahead and check what we're getting on PP bus. But while we're looking at it, Let's look at PPBus real quick. Let's make sure the orientation of the board is like this, since the board is in this way. So I'm gonna go and do a quick we'll flip it real quick. So we get the exact orientation. And there's PPBus G3 hot, and this is G3 hot charger. So we're gonna go ahead and check this top area. So we're gonna go ahead and put the black probe on the ground and then go from there. So we're gonna go ahead and test this. All right, so let's see what we got on the board. We're gonna go ahead and put negative, the black probe to ground, and we're gonna test the positive side to the positive side of G3 hot. We are getting 0.21 volts right now, okay? Out of curiosity, let's disconnect it and let's plug up the battery. Plug it back up. Remember, we are still getting 5 volts. And go ahead and put negative probe to ground, and then positive red probe to the positive side of PPBus 3.3 hot. And we are getting 0.22 volts. Out of curiosity, what is the charger saying? 0.22 volts as well. Okay, so let's go ahead and remove power, disconnect the battery. We're gonna go ahead and test, see if there's a short. What we're gonna do is we're gonna put the meter and test for a short. So now red probe to ground, black probe to the PPBus G3 hot. There is a short. We're getting 25.4 ohms. So you should be getting 0, which is a short on ground. So there's a short to the ground right now. The short to ground on PPBus G3 hot, which is actually pretty cool because it should be a little bit easier to find. So what we're gonna do is we're gonna take the board out. We're gonna go ahead and remove the board and see what is the cause of the issue. So we're gonna go ahead and take the board out. We already disconnected the battery, so let's take this board out real quick and go from there. So one thing about trying to figure out if it's a short on PPBus G3 hot, that's a good thing. I mean, it's not a good thing, it's bad, but it's a good thing because you know that that area is what's causing it not to turn on, and go from there. The best way to find out if there's anything going on with the board is take the board out and then try to see if there's any heat arising when you plug power into it, and see if there's anything showing up or getting really hot on the board. And usually when there's a short, the short starts sending signal to the ground and it gets really hot. So, you know, when you want to see something get hot, you're sending power to the ground and it causes it to, which is why we call it short to ground. Mind my finger, I smashed it the other day. Short to ground. So when you put electricity to ground, it creates a lot of heat. It could cause a fire. But in this case, the board, you'll see that the board is getting really hot and that area is shorted to ground. And that's how you see heat dissipating from the board. So then you kind of get an idea like, okay, that's where the short is because electricity is flowing to that side and it keeps touching ground. And that's where you start having the power showing all the heat where you can find the short. And if you don't see anywhere that it's short when you inject voltage into it, when you plug power into it, then you have to inject voltage into that line to see where it's coming from and see if the short shows up when you inject voltage. And sometimes there may not be enough voltage injected. So when you inject voltage into PPBus G3 hot, you just got to make sure that you remove the fuse and then go ahead and inject voltage in there on PPBus G3 hot and then see where the short is arising. And if you don't see it, it is wise, but carefully, but wise, raising the voltage a little bit in increments until you see heat rising. And your best friend to have that job done is a thermal camera. And good for us is that we have a thermal camera on the microscope. So we don't have to use, I always still use it as a habit because it's faster for me, but you guys get to see it in real time why it's getting hot. So makes the repair process a little bit easier. And the customer is aware that the board repair is important for her and she wants to retain the computer. It is cheaper to go ahead and get it repaired than just buying another board. And we're going to go do that. We're going to go ahead and get her board fixed and hopefully up and running, and hopefully it doesn't die again. We did see if she was using a knockoff charger. She was not, she said she had a 96, and she did buy a brand new 96 from us, but we will go ahead and refund her when she comes back. Just told her to bring the charger back with her, and then we will refund her that and apply that difference to the board repair. Because at first, when she came in, the computer was at turn on, and as soon as we plugged up a genuine charger to it, it turned on and it held charge and was charging, and then that was it. But it magically died and basically got a short after we closed it and we put it away, and then we opened up the computer to see what else was going on. And because she came in for a no power issue, the power was turned on, and then we noticed that her speaker was blown, so she has to go through a speaker replacement because the speaker was rattling really loud and it was blown. So now that repair turned to a speaker replacement instead to a board repair because the board did die, which was originally what was the issue originally, and it decided to rear its head finally in front of me. So that's okay, because that's what we're here for. We are a board repair shop, and that's what we specialize in. And we're going to find these issues, and we're going to diagnose these issues, and we're going to beat these issues. And then we're going to give customers a great experience and save them money. So that's what we're here for, is to save you money. Plus, you're also supporting a small business. So maybe one day we'll be bigger than small, but for now, we're trying our best to help the community, keep them in their computers, because, you know, Mac products are they're really good. They're really, I mean, I can say some are good and some are bad, but they're powerful. There could be a few things that need to change, but we don't like, let me go ahead and use my finger tweezers on this one because I don't want to accidentally, you know, hit the capacitors on the side over there. We're good. My nails are good, but I don't want to hurt her board. So here we go. Pull these off. And we got a few more things we got to pull apart. We also just recently, I don't know who you guys, I don't know if you know what this thing is, but there's a thing called Repair Wiki. It was founded by Louis Rossmann, and it's a contribution of all repairs, manuals, kind of like diagnostics of issues. If you want to get into the repair space, I would highly recommend you go and give a shout out to Louis Rossmann, and you know, also give credit to where it's due, and we give where credit is due. And Repair.wiki is honestly, it was ingenious, and it's just a beautiful thing that, you know, we use it. You know, I use it sometimes if I come across it you've never seen. I try to take a look at Repair Wiki and see if anyone else has seen it. And then most of the Repair Wiki thing is board related, but not everyone wants to take on board repair because board repair is complicated. It takes a lot of knowledge to understand how to read schematics. But if you dedicate your time in a couple of years, you could be at least somewhat proficient to understanding how to do board repair. But it doesn't happen overnight. And I say be patient with yourself when you're working on these computers, because I wouldn't want someone working on my computer if they haven't spent a lot of time understanding, you know, how the boards operate and what's going on with the boards and how to fix them. And then they'd take a spin on my board, and I would hate that. So I'd want to make sure that you guys are well aware that if you want to learn this, make sure you practice on your own boards. You know, buy computers that are broken and teach yourself. And there's nothing wrong with that. There's, you know, if you mess up, it's okay to mess up. It's okay to fail, because failure is part of growth, and failure is part of being successful in life. Because if you never failed, you would not know how to deal with failure. And being a failure at something doesn't mean that you are a failure at life. You just failed, but you should use that failure as knowledge and information. It's like, you know what? I made a mistake there. I'm not going to do that again. And those are lessons in life, and that's very important for repairs. So learn the repair process. Okay, I did this wrong, and I'm not going to do that again. And I did this, but as long as you do it on your own computers, you'll be fine. You know, I mean, obviously financially, if you spend a lot of money on a computer, I would never advise someone buying a computer that's worth like $2,000 that needs a repair and you've never done it before. I would always say start off small and then work your way up to the top if you ever want to start repairing things. We need Torx 5. And we got that there. Got to disconnect that. That's disconnected. And we need Torx 8. Now, pull these up, pull these up, pull this up slightly. There we go. Board is out. Nice and delicate with it. We're going to put this to the side. We're going to see what's going on. Before we even plug up anything to it, we're just going to do a little visual inspection and see if I see anything that's kind of suspicious on the board. Try to see if I see any power issues, any liquid damage, and I think I see something that's a little suspicious. Is that dirt or is that corrosion? What is that? Sometimes the customer is not always honest, or maybe they are honest and it's just dirt and grime, but I see something that is curious. So let's see what you guys see with me. That looks like it's a bunch of grime. Nope, it looks like it's just dirt and dust, so that's not bad. So just double checking, because I see some color over here, but that's just a bunch of dust, so that's okay. But you know, the elements are dry, so it's not really causing any issues. Don't see anything there, so I'm still looking, see if I see anything on this side. Still a little dust on this side. Okay, nothing crazy. Okay, cool. All right, so what we're gonna do is we're gonna go ahead and put power into this and see if we see any shorts on the board. So I'm gonna go ahead and inject. We're not gonna inject voltage. We're gonna go ahead and give it a regular multimeter. Excuse me, USB-C meter. And we'll see if we see anything on the board here. So we're gonna go ahead and look, see if we see anything. So I'm gonna go ahead and get my hand tool out because it's faster for me, but I'll let you guys see what we see. Okay. Okay, I'm waiting for our tool to turn on. Just patiently waiting. There it goes, turn on. I think I charged it all the way. Should have some battery left. Good, we have battery. So I'm gonna move this real quick and I'm gonna try to see what I see under the microscope. And if it doesn't show up on your thermal camera, that's okay. Make sure you check both sides. I'm gonna go ahead and disconnect this. I'm gonna flip it over. I know that port's bad. That port's not bad. That's just a bad USB-C port. Still use it. Still works. Okay, still checking. See if there's any heat showing up on the board anywhere. Okay, there's nothing. All right, so we have to resort into injecting voltage into this. So that's all right. Let's go ahead and find out what is causing this problem. So we're gonna go ahead and turn our voltage injector. We're gonna go ahead and remove one of these fuses. And then we're gonna see what's going on with this area. We're gonna go ahead and do this real quick. We're gonna go ahead and check this out. We're gonna go ahead and remove one of these bad boys out. You're gonna need to remove both. I'm gonna go ahead and turn the heat up. We had this set to 150 degrees Celsius. But what I'm gonna try to do is This is just a piece of plastic, not a really big deal. Keep the heat away from this area right here. This is just a little piece of tape that can be removed. Almost off. Almost there. And I like to spin it around a little bit to keep the stuff flat. There we go. All right, put this to the side. It's pretty easy to lose. Okay, cool. All right, so what we're gonna do is we gotta solder on this to ground. So what I'm gonna do is I'm gonna put this right over here on this side. Put on the edge right here. Just a little bit of love. Just a little bit of love there. Let me just solder her down. That's gonna come off. Clean that up because of the rubber. I've used this so many times. Let me just get in the way. There we go. Okay. Because of the there we go. It's on. Soldered on. Okay. So the next thing we need to do is inject voltage. We're only going to use 1 volt. And we're going to inject the voltage in it. We don't solder the voltage on. We use a little injection. Go ahead and input this area. We're going to see what we get. But first, let's see when we do this. Okay, so we do have a short for sure. 0.4 amps is showing up. So before I do this, we're going to go ahead and pull this bad boy up real quick. Let me go ahead and do an overhead. See what I'm seeing on here. See what we got. We know this. Okay, we know there's heat coming up somewhere. Question is, where are you showing up? Before I do that, let's cool this down a little bit. Okay. It's 103, 104 degrees. And keep this heat up right there. You just want to cool it down a little bit. Okay, cool. All right, let's see. What are we getting? Okay. I'm not getting anything on this side here. I'm not seeing. Move to my left hand real quick. All right, I'm gonna try to inject the voltage again. Let's see what it does. Got 0.42 amps here somewhere. I'm gonna go ahead and 1.2. Let's see if it climbs up. What is that area right there? Oh, hello. And I found the short. Okay. All right, so found the short. So I found the short on the board. So I'm gonna show you guys where it is. Go ahead, I had to raise the voltage up a little bit like I was discussing. So basically, the short is right here. I'll show you on the microscope real quick. And I'm gonna point it right where it's at. So the short is in this area right here. I can get this area to look down at it. Oh, that makes sense. Okay. So I'm seeing okay, so I don't know if you guys see it. Here, I'm gonna show you guys on the microscope camera, or that one's not letting me show anything. Right here, there is the heat rising in this area right here at the speaker amp. Speaker amp is the issue with what the computer is, why the computer is not turning on for some odd reason. The speaker amp has some kind of issue going on which is preventing the computer from turning on. So this area right here, you can see it. I don't know if you can see it. There you go. You see it right there? That area, if I'm not mistaken, it's the fuse amp right here. So I'm going to show you the amp that's getting hot. So the area that is in question is right here. That guy right there. This guy right here is why it's not working. At least so we believe. Now we're going to see what that is and see why that's causing that. So I have an assumption. I'm going to raise the voltage up just a little bit more for my curiosity, just to see if it gets hotter. And it did. So we're going to go ahead and turn this off. We're going to go ahead and try to repair that area, remove it, and see if the short is gone. But before we remove it to see if the short is gone, we're going to check and see what that is. Just to tell you what that is. So you got speaker amp, speaker amp, speaker amp. There should be a PB bus G3 hot. And there's PB bus G3 hot right there. And that's what's getting hot right now. So this area is getting hot. Now, one thing about MacBook Air, MacBook Pros and MacBook Air M1s, I've noticed that if the speaker amp goes bad, the computer will not turn on. So what's funny is the customer did come in and we noticed the speaker was rattling really loud, and the computer stopped turning on. So more than likely, that could be the reason why the speaker's not working properly, but we're gonna go replace that area, and then we're gonna replace, if it continues to rattle, then the speaker was already blown because of that area right there. So we're gonna go ahead and desolder that area and see if the short is gone. So we're gonna go ahead and do that. We're gonna remove this bad boy. We got a donor, which is great. So we have some donors. So we're gonna go and remove this guy. I'm gonna remove this guy out of the way. Keep the hot air from, well, you know what? Hot air is gonna transfer to that. So we need to put gaffing tape on her speaker connector, because that is gonna get hot and it's gonna melt. So we need to cover it up. just for precautionary reasons. No, it's not good enough. There we go. All right, so, all right, let's begin. We're gonna go ahead and remove it. Point it away from the area that is going to, you know, get the heat away from it. So this little guy right here is the bad boy. You'd be surprised, like, wow, PB Bus G3 Hot goes out, and if the speaker amp goes out, so does the computer. It's like, if it's like the PB Bus G3 Hot line goes out, then on the speaker amp, then the computer doesn't turn on because the bridge has been broken. Okay. All right. All right, cool. Now let's see if the short is removed. Now that we removed that, we're gonna go test and see if the short is gone on PB Bus G3 Hot. We're gonna go ahead and put red probe to ground. And it's gone. The short is removed. All right, good. So the short is now gone because of that amp. That speaker amp was right there. So the short is gone now. So what we need to do is clean that area up and you know, get it ready for a new speaker amp from a donor board. So this was the culprit right here. This guy right here. This guy was your bad boy. This guy is a no-no. But you know, the funny part is that the speaker on the right which was rattling, which would be the right facing the computer, which was this side where the speaker was rattling. So now we kind of know why the speaker was rattling, and now we know why the computer wasn't turned on afterwards. So if the speaker is not rattling anymore and it actually works normally, then it was never a speaker the speaker never needed to be replaced. The speaker was giving us a signal that something was about to die. And you'd be surprised that speaker amps makes this board die, which is an experience I've already kind of figured. Now that we know, it makes sense. All right, so I need to clean this up real quick. Find my... Okay, so let's go ahead and clean this all up. You see what I'm doing here, guys? Everyone likes to rub these things down because like, oh, you used to rub it with the thing here and blah, blah, blah. Me, I'm a little bit more paranoid. Plus, you gotta have delicate hands to do this. Okay, cool. All right, we got that removed. We cleaned it up. I'm gonna go ahead and add a little bit of alcohol in this area just so we can clean it up. Sorry for the shakiness, but that's just the articulating arm. I wish it didn't shake as much, but okay. Cleaning this area up to prepare for another chip. So I'm gonna go grab a donor board, put some gloves on because I'm about to handle some lead, and take a donor chip off and get that speaker amp working. Now we need a donor board. Let's get one. We need a donor board. Ooh, Oreo. All right. We have a donor board right here. We got a lot of donor boards here. But what we need is A2141 donor board because we need to fix it. You can't fix it if you don't have a donor board. I mean, we could fix it. We just have to order a chip at that point. But for time, in essence of time, we are going to use a donor board to fix it because there's 4 speaker amps on a donor board. And all we need is 1. Now the question is, where is the board? I swore I had a A2141 donor board somewhere. Ah, of course. We moved it over there. That's all right. That's what we're here for. Let's see if it's over here hiding. There it is. All right. We got a donor board right here. I'm going to move this away. I'm going to take this chip off over here. This is a donor board, and we know this bad boy. It's good. I don't want to damage this board's components on the side because we need it for repairs. So if we ever need one of these, and one breaks or something, we have spares. So we don't want to do anything we don't want to do. Actually, I could find the area. There it is.
Does it have to be this brown?
No, it could be solder wick.
It says no clean flux.
Yes, that's what it's called.
This one's $5.
Yeah, buy 2 of them.
And the width is the exact same.
Yeah, get that.
And it's the same.
Perfect. Get it.
Shape.
Go ahead and buy it.
One's $20 and one's $5.
Oh, get whichever one. It's copper. It's solder wick. It's basically copper. It's it's perfect. We need it. So if I pull this off delicately, which I will, I'm gonna have to reball it. I might not have to if I pull it off just enough without losing any solder balls. Nope, I didn't. No biggie. Now I'm going to go ahead and try this again. Put this.
Okay. It's the model number would be on the bottom of the computer too. Not the serial, just the model number.
There we go. All right. Try one more time, but we're going to be a little bit more delicate with it. Perfection is a problem. But it has to be done right. Has to be. Okay. All we need it to do is be perfect. Okay.
Let me check real quick with
There we go. Perfect.
the ignition and see if we have that battery in stock. Do you mind holding for just a minute? Okay, thank you. I'll be right back. Hey, do we have any A1990 batteries in stock?
Yes.
We do.
Pre-owned batteries. Yes.
With the cycle count?
300 or less probably, but we do have some batteries in stock that are pre-owned. If they want a brand new battery, you have to order one. All right, guys. So this is good. So we got it working right there. Look at the balls now. That one's good. Here you go. That is actually ready to go. So let's go ahead and do a little bit of this.
Pre-owned battery typically has a cycle count less than 300 on it. So it's like an A grade
There we go.
or B grade battery.
Perfect.
So the
It's ready. All right.
an A grade is going to be.
All right, so we're ready to transplant the chip onto the board. So let's get it ready. So what we need to do is put it in position.
So A grade battery with parts and labor is going to be right at 235.40, and we would have to order that.
Okay, so what we're gonna do, I'm gonna put this to the side real quick.
A grade. It's about $65.
There's that.
New battery is going to be $90, and A grade would be around $218. It brings the cost down about $30.
So we're gonna go ahead and align it.
About 3 to 5% safe. So if we ordered it tomorrow, it would be here by next week. Assuming that there's no delays with the mailing system, because we're kind of at the mercy of them. So.
Did that even go down? No. It is right there, trying to get it flush.
Yeah, and I mean, if you have any concerns about getting a pre-owned battery, my opinion about it is that it's better to get a battery that's been used. Sometimes when you order a new battery, you can even, this happens with brand new computers too, you get them out of the box and the battery is dead because they haven't been used. So with a pre-owned battery that
here we go. Circular motion.
And high cycle, yeah, there's a warranty. We have I think it's a 60-day warranty for the pre-owned. Yeah, and then even comparison,
There we go, and it's on. All right, let's see if it's repaired. Do a little drop right there, and wipe it down. Now let's see if the short is gone. See if the short is gone now. Still, the short is gone, but let's make sure the short didn't come back. Does that make sense? Yes, it does. So let's do a quick test. Good, 0. We're good. The short is not back. That means we put that on correctly. So let's go ahead and solder back on the 12-volt fuse. We're going to go ahead and put this baby back on. You handled that call very well, by the way. And we're going to go ahead and solder this bad boy on right here. I'm trying to keep it. We need this to be a little bit more. Okay, let it continue. To make sure the other one grabs on the other side. You don't want a partial grab. You want a full grab. There it is. There we go. It's on. All right. So let's go throw a little bit of alcohol on that. Cool it down a little bit. All right, let's do one more. This, instead of testing it, we're gonna go and plug it up and see if we got 20 volts, or at least get some amps on the board. So let's go ahead and pull that off, and let's see what the reading says. Yay! So we got 0.37 amps, 5 volts. That is giving me some good positive look right there. So what I'm going to go and do is I'm going to go ahead and do a quick check on the multimeter, see if we're getting 12 volts, obviously minimum 12 volts on the board. So we got power going in. So let's go and see if we're getting 12 volts. The multimeter, 12.60 volts. That is a beautiful short removed. And there you have it. We're going to go ahead and put this in the chassis. So we got 12 volts, 12.60 volts on the fuse. Everything is now removed. The short is removed, and it was a speaker amp, IC power chip for the speakers. Could be the possibility why the speaker amp was rattling. So we solved that on the board, fixed it, and we went from there. So the good news is that we're getting 12.6 volts. Yes, the USB-C meter says it's 5 volts, but it's giving us 0.3 to 0.4 amps, which it may be in recovery. It needs to be connected to a battery, and you start getting 20 volts. Sometimes it will say 20 volts, but it just depends. But we're gonna put it in chassis and make sure to see if it's repaired. Okay, so I got the computer put back together. There's no screws on the top case. Let me go ahead and switch over real quick. This right here is, there's no screws. It's just gonna do a temporary opening. We're gonna plug up the multimeter to this real quick. The USB-C meter. I keep saying multimeter because I've been dealing with a multimeter all day. So we're gonna go ahead and plug it up. I'm gonna see if the Apple logo shows up, and we're gonna turn it off. If it turns on, we're gonna see if we get 20 volts. There we go. We got 20 volts, and computer's turning on. Looks like the fan spin and the Apple logo. All right. Well, there you have it. That turned on.